Hi everybody, welcome to another class. So in this class we're going to talk about numeric literals, and I separated it with the integer literals and floating point literals. So for the numeric literals, I just want to give you one example. But before that, let me explain what it is. So JavaScript numeric literals indicate integer literals in different base as well as floating point literals base 10. So this is decimal system, but we have other systems too, like hexadecimal, octal, and binary. With the decimal is human reading system. Computer is doing things in the binary system, and we have also hexadecimal and the octal. Anyway, octal is for 8 digit, binary is for 2 digit, hexadecimal for 16 digit, and last one, decimal is 10 digit. I mean, I'm talking about, let's say, for the decimal system, we counting from 1 to 10, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, and we putting another one, like n number, it continues. For the octal system, you're making it like 7, 7, 7, or just think like 0001, that in the 8-bit system it will count it 7 times. Or you can directly say you continue until 7, then you continue with another way again. And for the, it was about octal, and we have also hexadecimal. For the hexadecimal, we have 16, which is you continue until 9, and you continue like 1, 2, 3, 4, 5, 6, 7, 8, 9, and you're putting there big A, B, C, D, A, and it continues in that way until F, and you're putting n numbers for the continuous. And then lastly, we have binary base, which is 0 and 1, and 1, 0, 0, 1, 0. It continues in that way to count the things, which is computer doing exactly like this. We're counting like 1, 2, 3, 4, 5, etc. The computer doing that 0, 1, and 1, 1, and etc. It continues in that way, okay? Just put in your mind, I don't want to give you many more examples about that right now. Just know about binary, decimal, which is you already know about decimal. Just learn about binary. Binary is between 0 and 1. So it is false and true, the computer logic. And the octal system is for about 8-bit system. I mean, like 0, 1, 2, 3, 4, which is in the computer. We're talking about 16-bit, 32 bits, etc. Right? It's all about these topics. Okay. So 16-bit system, which is until the 16-bit it makes operation. So if it is 64-bit, then we know it is continue until 64. So for the binary, it is 1 and 0, and for the octal, it is 8-bit. For the hexadecimal, it is 16-bit, and for the decimal system, it is not 10-bit because computer not working like a human. Okay, but we created that. So integer literals, what is that? But before that, let me give you numeric literals. One example: we using minus 1.1 to 123.3. Do you think we can output that number out like with that way? Let's say const my float number in that way. Now, as you see, we have here equals and minus together. Do you think the computer will confuse, or exactly JavaScript language will confuse during to see that? So I don't think so, because it's not minus equals, it's equals minus. But in some languages, it can be some problem. So let me try it out and see what will happen. You can just say console.log, and you can put this my fn there. I mean, let's run it and see what will happen. We will try also with the parenthesis and see what will happen with another way too. So let's see the output first. The first output will be what? Okay, we're waiting. Okay, as you see, it's already give us the output in the right way. So in JavaScript, it is like that. If you try in Python, maybe it will give us different output. So we can try later, or you can just directly try it with your editor. Okay, if we do it in that way, with a separating way, maybe it works in a good way. Again, if we do it in that way, because we're not reading like type over, etc. So let me go there and put it in that way. Yeah, like this. So let's run it again. And after that, I will continue directly with the integer literals. So for the integer literals, let me start. A decimal integer literal is a sequence of digits without a leading zero. It's like so a leading zero is an integer literal or leading like zero in the binary system. So in the cases now octal integer literals can include only the digits between 0 and 7. Okay, so a leading 0x, which is we're talking about still 0. In the case hexadecimal integer literal integers can include digits until from 0 to 9. Then it continues with the like lowercase af until from a to f, like 1 to 0, 1, 2, 3, 4, 5, 6, 9, and 6, 8, 6, 7, 8, 9, and it continues like a, b, c, d, f with the lowercase and uppercase. It is we're talking about hexadecimal, okay? For another one, which is 0xf, if you put there, for example, 0xf, it means we are talking about 15, okay? It is exactly 15 because it is 0. We started from 0 and it continues like 1, 2, 3, 4, 5, 6, etc. until E. Then it continues with the F. F is the last one. It is hexadecimal until 60. Okay, this is, let's say, hexadecimal. The decimal. Okay. Uh, Another one, which is, let's give example for the octal. You can say for the octal, for example, 0 x, and we can just call it in that way. 0x a, let's say a, it's equals 10. It means octal. What it means octal, like 0x is until 10, but in octal system we can just call it in which way, we can just say 0 to 7. So we can show it in different way. We can just say like 0 and O. In that way, it is exactly from 0 to 7, like this. This is 8-bit system. You can think like this. This is octal. And then we have decimal, from 0 to 9. Then we continue again with the 1, 2, 3, and this way. And for last one, I think we can say for binary, for example, for binary, we can call it which way? We can just say 0 binary. For the hexadecimal, we're calling it 0x. Okay. For the like this one, 0x means that this is hexadecimal number, and we can put the value there, etc. And this is 0, and we have O here, lower O. It means like this is octal, and we have here B, 0B. It means like this is binary number. Okay. So for the binary number, you can think anything else. You can put anything else even if you want, but you can just think anything else about that. Okay, it's just representing what we are thinking about. So it was the case about that, but maybe for the octal, we can just say this is octal system, 8-bit system. It's representing 8-bit system, which is the calculation of all this. If you put 1, 1, and 1, what would it be? Like 1, it's the power of 2, it's 2, 3, and the power of 2. For, sorry, 2, it will be 8, and, sorry, 4, and the power of this one, it will be 8, and it will give us 16 as a number, which is we're calling the octal system in this case. Like it's 8-bit system. It's calculating if all of them like this, then it gives us the value. So anyway, um, then I explained it to another two. In the binary system, it's 0, like 0 to 1. I mean 0 and 1 in that case. Okay. Then you continue again with another values like 0, 1, and so 0, 0, 0, 1, and 1, 1, and 1, 0, etc. Okay, the calculation. So okay, I think it was already easier to understand. Integer literals, we can call it uh, in the easy way with the example that we can say console.log. By the way, let's say uh, first, let's say first, or let's say decimal number like this, const decimal number equals, let's say uh, let's say 11, okay, like this. And so then we can say const let's say octal number right now, octal number, and we can just put here what. So as I have represented, we can call it like O with the O, right? So what can we say for this? Can we represent it with the this way? So let's say, sorry, this way, octal digit expected. Let's say 1 in this case. Okay. So the another one, let's say is hexadecimal. So you can just say hex number, hex des number, and we can just call it with the 0x, and we can put 1 or f, etc. Okay, we will check each of them in the right way, but before that, let's do the same operation with the binary number. So we can also say const bin num, like binary number. We can just call it like 0, 0, b, and 1. We can just say like this. Now I want to output all of this stuff. We can just put their decimal number, let's say this, and let's make 4 times like this. The second one was octal number, right? The third one is hexadecimal number, and the last one is binary number. So if we run all this stuff, by the way, you can put this semicolon after all this operation, like this. So now when we run that, let's put this, guys, into comment. When we run that, let's see what will happen. We will check it in the right way to understand what's going on. Yeah, as you see, it is 12, it is 1, because in octal number we had it 1. So if you do it 5, it will be 5. It is 15, as you see, 0x and f, because we said the hexadecimal system until 16, and f is the end word or letter or the representing the 15. So if we do it e, for example, it will be 14. So let's try together. We can try everything. So, and let's do it like 5. It will be shown us the 5 octal number. Okay, you can just check. 0 binary is 2, and we can see also the 2 in that way. And I will show you their types together in that way. As you see, this is 14 now, and this one is decimal 12, and this is 5 in the octal system, and it is in hexadecimal system 14, and the last one is binary 1. So I want to do one thing now. I want to, by the way, it can be 0 or 1, sorry, yeah. We can't count until like 5 or 7, because it doesn't work. Binary digit expected only 0 or 0 or 1, okay? Two things, because it's counting 0, 1 and nothing more. 0, 1, 0, 1, etc. And it continues until 7. So if you put okay, if you put 8, it will say octal digit unexpected, because it's from 0 to 7, okay? In that way, we must put there 7. So it is until forever. I mean, we can use that. In here, we have f, the last number for representing the hexadecimal number, and binary number is last one is 1. So as you see, it is like that. Now I want to put type of to show you what they are. Let's say type of in that way. So I want to show you for each of them what they are, and here and this one. Okay, when we run that, see what will happen. What is their types? It will not give us number now. It will just directly show us the type of them. Okay, let's see what is their types. Yeah, their types is number. Well, I don't know why it doesn't show as a different way, little detailed way. I'm not sure about that, but I can check it exactly with way. Uh, Maybe I don't know. I think it's just number. Okay, just think this is decimal, this is octal, this is hexadecimal, and it is binary. Just you can be sure that what we are doing. Okay. Because type of normally has to show in it, but I don't understand why not. Well, in all programming languages, it works different way. That was the rules that I showed you how we can do this stuff. Let's talk about floating point literals. So in floating point literals, we have can have the following parts as unsigned decimal integer, a decimal point starting with the dot, a fraction, another decimal number, and an exponent. So to exponent part is then a little bit different. You follow it by an integer, which can be signed preceded by plus or minus. The floating point literal must have at least a digit and either decimal point or etc. Okay. For example, we can say digits, that digits, and we can make there such a different operation to count all this stuff after all these things. Okay. So what I'm trying to say you, I will show you now. Let's say for the floating number, let's say const float num like this. You can put this one there and you can just say 3.4 thing blah 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 like high number. You can think in that way. And let's say for another one like const float num one, let's say one for that, and let's put such a number like this. And you can also put const again. By the way, this const is from here. Float num, you can just say plus float num 2 plus, you can just say 3.1 a. You can put a, for example, and you can say plus 12 if it works. As you know, this is exponential number, right? And we can use also in that way float num 3, and we can just say 3 sorry dot point, and we can put e minus like this. As you see, this is exponential numbers here. E is representing the exponential point. So now if you console out all this stuff, let me take out all this stuff what they will say us. So let me tag in that way, uh, like this, and like this. Okay, and this one. Okay, wait, what's float number 2? No. Okay, just tag this one there. So when we run all this stuff, they will give us such a numbers like in the realistic way, so we can check all this stuff together slowly. So when we run this stuff, I will show you the exactly answer what it is about exponential numbers, because as you see, this is a floating point number, this is exponential number, and as you see, so the first one is 3.14, etc. This is pi number. The second one is with the dot. As you see, the dot is representing as a prefix the zero, like 0 point, etc. And the third one is, as you see, exponential. So when you put there such a e, it's representing such a long number as exponential. So if you put there plus 12, it means that we want there 12 times zeros in this case. Okay, if you say 30, it will give us 30 zeros. It will give us exponential way. I will just show you that. Okay, no worry. So let's run it again and see what will happen in this case, how it works. So I run it again. it says 30. It didn't show us. So what if we say again 50? If it is, sorry, not this one, it was that one. If we say 10, because we are tagging the explanation of this one, what will happen? It will give us 10 times zeros to make it longer in operation, isn't it? Right. Here, as you see, 10 times 0. So we don't need to write, for example, like this. Listen, if we tag this e plus 10, we must put there 10 times like this. We don't need to do that, okay? We can just do this operation in that way. We can just say 1 and, sorry, okay, 1 plus, and we can put a and, sorry, 1a, and we can put plus 12, etc. Like 12 times zeros we want with that one. So e plus 12 means that 12 times zeros we want in this operation, like after 3.1, right? That's the case we are talking about. So it means we are putting there 12 times zeros to addition for the exponential. So the last one is dot plus dot 1e minus 23. It's representing such a number that in this case, okay? This is another point for the floating numbers. And as you know, this is pi number is generally we using like this kind of stuff. Or we can use this one too, like 0 point etc. representing that one. That's good. I mean, good point. You catch it. So do not use an object literal at the beginning of the statement. This will lead to an error or not behave as you expect, because the will be interpreted as the beginning of the block. So yeah, it was a point. I mean, now we can continue with another topic, which is we will talk about object literals. After some minute, I will continue with another class. Thank you so much for watching. Let's continue with another lesson soon. Maybe I can put also the class name, like the topic. The other one will be 1.3.4, 1.3.1 minute, 1.3.4, and it is object literals. Okay, we will continue from here. Thank you so much for watching. See you in another class. I hope you understand. It was the deep topic about integer literals and Boolean, floating point number literals. Okay, so it is good really to know about binary, octal, hexadecimal, and normal decimal system that we're using. For the computer, binary is much important, and also to know this the plus e, and to make this zeros longer, you don't need to write like a slave each time the zeros. Just be sure about that. Thank you so much for watching. See you in another class, and it was great to explain all this stuff in depth way. Thank you for all this stuff you understand.